All right, so now that we have some basic understanding of the conditions for operating the significance test for a difference in two proportions, let's go ahead and execute it. Let's look at the example that we were just talking about in the previous video about the children coming to school without breakfast. So remind ourselves, researchers designed a survey to compare the proportions of children who come to school without eating breakfast in two low-income elementary schools. A simple random sample of 80 students from school 1 found that 19 had not had breakfast. At school 2, a simple random sample of 150 students included 26 who had not had breakfast. More than 1,500 students attend each school. Do these data give convincing evidence at the alpha equals 0.05 significance level of a difference in the population proportions? So, do they provide convincing evidence is a key trigger that we want to test. We want to do a significance test. So what do we want to test? We want to test H sub 0 I'm just going to use the pen here. H sub 0. And our null hypothesis would be that proportion 1 is equal. Sorry, that should be a colon. Our null hypothesis would be that P1 is equal to P2. And then our alternative hypothesis, would be that they're not equal. Okay, so there are our two hypotheses. And of course we need to define our variables here, our parameters. So make sure we define P1 and P2 are. So this is where P1 is the true proportion. This is the same parameters that we just set in the previous video, so why don't we just copy them over. Okay, where P1 is the true proportion of students who go without breakfast at school 1, and P2 is the true proportion of students who go without breakfast at school 2. And we want to do this test at, oh my goodness, Microsoft, you're killing me, at the alpha equals 0.05 significance level that was given to us in the prompt. Okay, always make sure that we're stating the hypotheses as well as the significance level and defining the parameters. All must do items for the state plan do conclude. For the state step, that's what we want to do. State the hypotheses, the significance level, and define the parameters. Our plan is to run a significance test. So we will perform, this is where it can get a little bit weird here. We saw that our test statistic will be Z, but remember now we have two samples. So we're going to perform a two sample Z test for the difference of two proportions. That's what we're trying to test if conditions are met, right? So let's check our conditions. We need to check the random condition. It tells us that both samples are randomly selected. Then the 10% condition. It tells us there's more than 1,500 students at each school. So for school 1, the sample was 80, which is less than 10% of the sample size, right? right? We know the sample's at least 1,500, so 10% condition is met for school 1. For school 2, same basic idea in play here. The sample size given is 150, which is less than or equal to 1/10 of the 1,500, which is the school is at least 1,500, right? So the 10% condition is met for both schools. And then lastly, the large counts, okay? For a 2-sample z-test of proportions, really for any test or confidence interval for proportions, that's when we need to do large counts. So successes, this is where we have to be really careful. We need to make sure successes and failures for both samples are greater than 10. Okay, so successes in the first school, there were 19 students who came without lunch, and failures would leave 61 students who came with lunch, both greater than 10, so we're good there. And then in the second school, there were 26 successes of students who came without lunch, and that would leave 124 who came with lunch. So in all cases, well over 10. So we have the random samples met for both populations, the 10% condition is met, and the large counts met for both samples. So all of our conditions are met, which means we're ready to go on and actually execute the actual test. So in the do step, we should, I'm going to go ahead and use the calculator, save us some time. We should indicate that we're using the calculator and indicate the test. What's more important even than saying that we're using the calculator is to indicate specifically the test that we're going to do. We're doing a 2-sample or 2-proportion z-test. If you're using proportions, you should say proportions instead of samples, just to be clear. 2-proportion z-test. And then we'll indicate the things that the calculator asks us for. If we skip forward in our notes here, here are the things that we're going to need to enter into the calculator. Our successes and sample size from both populations, and then our alternative hypothesis. That's all we need is the successes and sample size for each population, and then the desired alternative hypothesis. So we can say successes 1, which would equal, again, that's the number of students in the first school who arrived without lunch. And then the sample size from the first population was 80 students. Excuse me. Then it's going to ask us for the successes from the second school, which was, 26 students showed up without lunch, right? And the sample size from the second school, which was 150 students. That's all we need to enter into the calculator. Let's pull up our calculator. That's going to be under Menu, Statistics, Stat Tests. And be careful to pick the right test here. We want the 2-proportion z-test. 2-proportion z-test for proportions. Okay, again, successes from the first population, 19 in a sample size of 80. Successes from the second population was 26 in a sample of 150. Our alternative hypothesis was that the 2 proportions are not equal. That's all we need to select. And then we're good to go. All right, and so then it spits out some values at us. We need to make sure we note the important ones. If we come back to our notes, our AP exam tip here emphasizes the important things. We need to make sure we name the procedure, which we already did in the previous step. We need to report the test statistic, which we'll note in a minute here, and the p-value, okay? So in the do step, we've named the test already. We need to identify the z-value, which was the test statistic, which is 1.168, and then we need to identify the p-value, which was 0.243. Okay, so name the test, identify the test statistic and the p-value, and now we're ready to go on to the conclude step. So we are going to compare the p-value to the desired significance level, which was 0.05, and so we can say because the p-value is 0.243, which is greater than 0.05, the alpha level, because it's greater than 0.05, we will fail to reject the null hypothesis. That shows that there is not convincing evidence of a difference between these two proportions. So the conclusion step is identical to what it was in the previous chapter. Okay, we compare p-value to alpha and either reject the null or fail to reject the null. And then we say there is or is not convincing evidence in context. So we would say, in this case, of a difference between the proportions of students who come without breakfast at these two schools. All right, so there's our first significance test for a difference of proportions.